This is the final presentation report for MSUM. I'm Jacob Karsten.
I'm Alex Neal.
I'm Emily Watson.
I'm Izzy Dioria.
I'm Abigail Moan.
I'm Nate Rons.
And I'm Tanner Wire.
So for the game plan and also kind of what happened during the competition is our original game plan was we were going to explore the ground level first and just kind of get our bearings to find where everything is. Then the next thing we were able to do was go inside and explore the cave. And then leaving the cave, we were going to go conquer the ramp. And the reason we did the ramp last was because if we had fallen off, then we would be able to at least have explored the whole ground level first.
So for the sensors and equipment, we had a fairly extensive sensor suite connected to our microcontroller. The primary microcontroller we used was a Arduino Nano 33 BLE because it had a lot of these sensors that we needed built in. The other few things worth noting that we did that were interesting this year was we used non-reusable lithium batteries because the energy to weight ratio is very good on non-reusable lithium batteries.
The layout of the area was fairly simple with only a couple of notable areas: the area behind the cave itself, and the plateau. I traced our travel path on the ground level and within the cave to show how we traversed the area with a basic plan for how we approached the objects that we found.
All right, the data analysis methods that we took, because the camera feed, the data feed, we screen captured, and so we had timestamps on both of those videos. The RPI, the Raspberry Pi Zero on board of the tank wrote data to a text file that was later extracted through a soft spot, which was our communications base. We were able to sync the data files afterwards because of these, the data feed, call outs, etc. This means we were able to sync up and make it really easy to analyze all of our data because the text files would sync up with our video feed, and it just made everything really easy. To analyze the actual text files, we used a Python program that would make graphs to our needs, and we just used them, and it had a timestamp, so we just had to look at the time on our video feeds and cross over. We also use the diffraction of the lasers that we've talked about previously, and the IR distance sensor. So we use our Logger Pro equations to get sizes of objects within a plane because of the diffraction of the lasers.
One of the areas of interest that we saw was on the ground level was the rocks that were behind the plateau. And if you look at our graphs here in the bottom left-hand corner, you will see that it does look like there is a spike in the object temperature. However, that's only one data point. And because the rest of the data points are a lot closer to the 21, 22 Celsius range, this data point could be considered an outlier because of that. And the rocks also appear to be white/pale as shown on the right-hand side in the images.
So for the cave, following our previously mentioned game plan, once we explored the ground level, we entered the cave, which we determined to be underneath the plateau. The ground was covered in a sand-like material that we were able to traverse, and putting it in perspective of being on the lunar surface, the sand-like material would be lunar regolith. And we were able to find two areas of interest within the cave, which can be seen in the lower right-hand drawing.
So in the back left corner of the cave, we found some what appeared to be almost glass bead-like pebbles. They were very reflective, and we used the laser diffraction to scale the size roughly. We most likely do have some error. And as we can see from the object temperature and the magnetic field graphs, there was no measurement of interest from these objects. Other than that, we were not able to tell much else besides visual appearance and what they could possibly be made out of.
So looking at the other side of the cave, we found some bigger rocks in the right-hand corner. And again, these rocks did not show a lot of data, but like Tanner said in the previous slide, we were able to use the diffraction gradient to determine the relative size of these rocks, and looking at the 2 data points that we have, or the areas of data that we have highlighted, we were unable to find any significant temperature or magnetic differences from these rocks.
In the front left corner of the cave, we did find with our infrared temperature sensor that there was an increase in temperature of about 4.5 degrees Celsius. And we found this increase in temperature multiple times as we scanned across the area. We did find that the ambient temperature in the cave was above the normal temperature that we were at before we entered the cave and once we exited the cave.
After we finished exploring the cave, we decided that it was time for us to go up to the plateau, or at least attempt to go up to the plateau. So we did our traversing of the ramp. There appears to be a colorful section of either paper or tape on the ramp, and we are unsure of what that means. In terms of the actual climbing of the ramp, it was somewhat difficult because our camera kept lagging behind, so we had to move we'd have to click the controllers once, wait for the camera to catch up, then keep doing that.
Once we got to the top of the plateau, there was a slight lip that we need to get over. This lip we found very challenging because the slope of this lip was slightly higher than the surrounding area. We were able to still see certain things while we were attempting to get up this lip.
Once we got up to the top of the ramp, but never got over the lip, we did see the white bucket with, or the green bucket with a white dot on it, and what appeared to be black beads or rocks next to the bucket. Other than that, we were able to see a basic perimeter of the plateau, and we did notice a magnetic field reading in the while we were at the top, but we are not sure as to what that could be. Other than that, nothing else was seen from the top of the ramp onto the plateau.
And then tragedy struck. As we were trying to attempt to get over the lip, it was proving difficult. So we decided to just try to full send our wheels to try to propel ourselves over the lip of the table. But unfortunately, our tracks got caught, did a 90-degree turn, and then flew off the table, landing on its side, pointing towards the opening of the cave, which you can see in the top left corner, which caused us, top right corner, which caused us to have to end the challenge before actually getting any data on the plateau.
Some takeaways that we got from this project were obviously time management is key. With any big project for this long, things can fall behind if we're not careful, and so time management for next year will obviously be an important thing to stress. Technology like what we use, the Raspberry Pis, the Nano, all the different types of sensors, the lighting, it takes time to get those things to be a fully functioning system. And so that kind of just wraps back into the time management. And then the last point is starting from the ground up is hard. We were given a lot of materials, but we wanted to do our kind of our own thing. So we started from the ground up, and that is hard. So, and then improvements for next time, maybe not starting from square one. So using more of the resources that we were given in the start of the project would be helpful, because then we don't have to come up with so many different things, if you will, different systems. Having a better sub-project management, so setting little goals to achieve over the course of the project timeline would be helpful. For the last point, we would like to test a fully functioning system more often. We obviously tested the system prior to the competition day, but when we did the tests, we ran into some bugs that would have just been better to catch earlier, so it was less stressful leading up to the actual competition day.
We just wanted to give thanks to our faculty advisor, Dr. Lindas, to Dr. Craig for setting up the course, to the judges for taking the time to participate, Any final thanks to Thelma, James, and Gabe for putting this all together?